Welcome, everybody. This is Tony Veroven. I'm an associate director with the National Air Filtration Association. This is a kind of a cool webinar because it is not focused on a particular topic here. This is actually based on a bunch of questions that we haven't had a chance to answer before from some previous webinars earlier this year. And also, if you registered or when you registered, you also were given an opportunity to submit a question to hopefully maybe not stump our experts today here. So, so again, thanks for joining us here. Today we have Bob Couture and Jim Rosenthal. Marisa was scheduled to be with us, but she's got a family emergency. She will not be joining us, so she'll definitely be missed here. So Bob and Jim, you'll have to carry the load here today. Just a quick overview of NAFA. NAFA is the National Air Filtration Association. We're really focused in on best practices in air filtration, education, and networking around the industry. And really, there's been no more important time than now when we're thinking about healthy buildings and clean air and keeping people safe, as everybody is pretty much back in person now. So if you are a manufacturer or a distributor or in this space, this is the place to be. Just a couple quick testimonials from some of our members. Basically say if you're in this industry, this is the place to learn and be part of the industry. So we do have an event coming up in April, mid-April. It will be in Atlanta. It's called the Technical Seminar, and that is where you're going to learn a lot of technical information surrounding air filtration, the science, a lot of research. We usually bring in a researcher or a professor of sorts or a researcher of sorts on air filtration or related areas there. So that's a good place to learn the basics. If you're in business development or sales or an engineer or anywhere in that area as far as air filtration, it's a great place to further your education. If you want to stay in touch with us, we have a lot of places that you can do that. We have the usual places like Facebook and YouTube. We'll share the recording of this on YouTube, and we also have a podcast. So you can go find us, look for Talking Air Filtration. You'll find that on pretty much every podcast player out there. So with that, thanks so much for your patience. We're going to get started and get over to, I'm going to stop sharing now. And now I'm going to hand it over to our panel here. So we've got actually Matt, Brooks, Jim, and Bob here. Matt, I'm going to turn it over to you. And why don't you go ahead and introduce our panel today?
Great. Thanks for everyone joining us. We really appreciate it. Looking forward to hear some of the questions you guys have, and even more some of the answers we're going to get from Jim Rosenthal and Bob Couture here. Looking forward to getting those questions in the Q&A section. If you look at the bottom of your screen, you can actually click in that Q&A and submit a question right there. If you do it via chat, we'll be monitoring that as well. But if you can get them right in the Q&A area, I will start shifting through those. We also had a lot of questions that were submitted as people registered. So we're going to kick off with a couple of those questions just to kind of get the ball rolling. And the first one we're going to start with is a real simple one, and I think, but I bet you Jim will give us some good information. So Jim, I'm going to throw this one at you. We had multiple varieties of this question, and it's basically, when should filters be changed, and what's your recommendation for frequency of replacement of air filters?
Well, theoretically, the idea is to change filters at twice the initial pressure drop. And that's a great idea. And some people follow it, certainly for the more expensive filters like HEPA filters and high MERV levels. I think that's a great idea. But what we found is that it really creates a big problem. Let's say you have a school district with hundreds and hundreds of filters. Some are ready to be changed, some aren't ready to be changed. It becomes a nightmare in terms of the actual physical changing of the filters. So what normally happens is we wind up with a set schedule, and that schedule is determined by how dirty the filters get over a period of time. So usually it's every 3 months. for pleated filters. And sometimes people go longer than that. I've heard up to 6 months, and some go shorter. And then there are certain areas, like in schools. I always use the example of high school with 4,000 students in the entrance area. Whatever, that air handler is handling a tremendous amount of dirt and lint and other things. And it's not unusual after 3 months to look at one of those filters and there's a 1/4 of an inch of stuff on there. And obviously it's not going to work very well. So that would be a case where you change it more quickly.
Great. Thank you. I think that was what I was hoping to hear. A lot of information there. Appreciate it. So moving on to another one that was submitted during registration. Bob, this one's going towards you. When would you prefer a pleated filter or a ring panel filter? And what are the pros and cons of both that you've seen?
Well, in the Boston market, I'd say it's 95% pleat to 5% ring panel. That pretty much has been driven by the plan and spec aspect of that, because the engineers specified pleats. In an area that isn't Boston with high relative humidity, then you're going to look at a ring panel a little bit more, because there's no water attacking the filter, the pleat, but there is water attacking the panel, the ring panel. So we don't see much ring panel activity here, but there is an application for it. And I think maybe in the South, you'd see a lot more polyester and so forth, because it's resistant to falling apart due to water attacking it. So that's what I would say. So just the difference is, one, the ring panel is all face velocity, and the pleat, because of its configuration, can handle a little bit more velocity because there's more face medium. So that's why we're doing better up here with pleats and not so good with panels.
Makes sense. Thanks, Bob. All right, another one that was submitted to Jim. I'm going to throw this one at you. What has changed in the filtration industry over the past 2 years, and what do you think is coming in the next 2 to 5 years in our industry?
Well, what changed was COVID. It changed the market substantially, and a couple of years ago, we were scrambling to come up with MERV 13 media because recommendations were going to that because the COVID was airborne and an aerosol, and we'd shown that MERV 13 filters were much better at reducing those aerosols in indoor environments. So that was a major move to MERV 13 filters. I think generally most of our customers moved up somewhere, either to a MERV 11 or a MERV 13, or many of them did. So that the market changed. Now the question is, how long is it going to stay that way? And how long is the MERV 13 bonanza going to continue? And I think, Matt, you said earlier that was in your area in Buffalo that it was reducing. The number of customers were backing off of their MERV 13 purchases. And in our market, I think it's held up pretty well. But the interesting thing to me is that customers are much more intelligent about filters today than they were 2 years ago. There's just a higher level of interest, higher level of knowledge. 2 years ago, you could go into a room and ask what MERV was, and half the people tell you it was a game show host. Got to try that joke again. So I really think today, if you walk into that room, 70% of the people are going to say, MERV, minimum efficiency reporting value, and I think that's we're as an industry, we're much better off today than we were 2 years ago.
Yeah, absolutely right. I would agree with that. I have almost become a little bit more popular in our network of mechanical and engineering type facility operators, because now you're not just the filter expert, you're the needed filter expert with all sorts of questions getting thrown at you. So it's great to see that that's kind of getting that spotlight and continue to get that spotlight. And we actually just got a question that was submitted that's kind of a follow-up to that. And Bob, I'm actually going to throw this one towards you on the same line. What does the filtration industry need to do to keep that momentum that was created and continue the improvement in what we're doing?
Well, I think that one of the biggest sins in the marketplace is that the installations aren't good. They leak, there's bypass. And if you've got bypass, there's no sense worrying about a MERV 13 filter. All the dirt's going to go around it, or all the viruses are going to go around it. So I think one of the educational duties we have is to get people to make sure their installation is up to snuff. And if it isn't, it's all sort of a waste of time. It doesn't really make any difference. A lot of people are putting up here MERV 13s and unit ventilators. That's a complete waste of time, because they are so leaky that it's a political thing. It has nothing to do with how good the filter is going to perform in a classroom or whatever, because they leak all over the place and they can't handle the static pressure of a 13. But people do it for political reasons. Unions put pressure on them to put 13s in classrooms, and it just doesn't work. There's not a band-aid that it works on everything. You gotta look at the application and then determine what filters you might want to put in there. But they have to make sure that the installation is good. And that, if not, it's sort of an exercise in futility.
Sure. So fortunately or unfortunately, there's no silver bullet. It's taking it case by case is what I'm hearing from you.
Everything's different.
Yeah. All right. Going along that line, there were a couple questions on actual particulate matter and sizes along that side. So Jim, can you kind of explain a little bit more the importance of removing that particulate matter, specifically that 2.5 size that the EPA really stresses and has now become mainstream throughout a bunch of different governing bodies to be able to say, hey, this is important stuff?
Well, I think there's really good data showing that PM 2.5, higher levels of PM 2.5 have negative health effects, and that applies for outdoor and indoor, and many of the particles indoor come from outside. So there's a outdoor to indoor transfer, and essentially what happens is they're attacking the respiratory system, and actually there are some other issues with even things like learning, and so I think it's an extremely important number to work with, PM 2.5. And what I tell people is make sure when you have a filter selection that those filters are very efficient, or at least moderately efficient on PM 2.5 particles. And we're saying PM 2.5, for those that don't know, it's particle mass of all the particles under 2.5 microns, and it's a standard, and there's also a PM1 and a PM10, but PM 2.5 is the current thing that we're shooting for, and I recommend that people look at that and pay special attention to efficiency in those categories, basically E1 and E2 in the MERV system.
Going along that, we have another question that was submitted. Microns between 1 and 3 have been known to carry the virus, but can you explain, and Bob, I'm going to throw this at you. So Bob, can you explain how the MERV filters actually address those 1 through 3, as well as the virus itself of what we're being told? And I think it sounds about right, about a 0.1 micron in size. So can you tell us how that kind of works out?
Well, the virus, the COVID-19 virus is pretty much 0.1 microns in size. Now that relative to a pleat, that's not going to get all of them. A 13 will only get around half or less of that size. So you need perhaps better filtration than just a MERV 13 pleat if you want to get rid of the virus size of 0.1. So I would say I'd be careful recommending the 13 if you're just shooting for that virus size of 0.1, because you're only going to get, but getting some of it's better than getting none of it. So if you get half, that's going to be better than nothing. And I would say if you can get 13s in the air handling units and so forth, that's probably a good strategy. Unit vents, no.
Could I add something to that? It's true that the viral particle is 0.1 microns or somewhere around there, but it doesn't exist as an unattached form. It actually has to have proteins and moisture to exist, because it's basically a parasite. It doesn't live on its own. So the target range is more in terms of like 0.5 to 3. I think most aerosols have been shown to be active in those ranges. And keep in mind that the way filters work, that the 0.3 is actually the place where the filter is the least efficient. It becomes more efficient for particles that are larger than 0.3 or 0.2, as they've found recently. And it becomes more efficient on particles smaller than 0.3. So in actual fact, you're getting higher performance than the MPPS at 0.3. So you do get a relatively large amount of reduction.
And adding on to that, Jim, that's been proven in multiple tests over years that efficiency actually does come back up around that 0.3 size.
Oh yeah, it's just the way that filters work. I mean, you have all the mechanisms of filtration, and diffusion works really well on small particles. And in fact, as it's really high at 0.1 and starts going down, and then the other ones are high interception and impaction and straining are high, and they go down. So the lowest point is right at the base, but you've got high here and high there. So yeah, it's definitely proven. In fact, if you look at any efficiency chart for filters, that's exactly what you'll see. It's always a U. It's not a straight line. It's a U.
Perfect. So, Bob, especially being in a colder weather climate, how do you see the masking tying in with IAQ? And have you seen any studies or done any studies yourself that have shown the reduction in particles or something along those lines?
Up here, it's not cold all the time. We do have summers. But I think your question would relate more to UV, say, and ionization than it does filters. Filters seem to work if it's 30 degrees out, 20 degrees out, 85 degrees out. I don't see a big change in how filters perform. But in the other two means of cleaning air, I think they do come into play.
Great. So going on to that, then another question that was submitted, Jim, and I think this was perfect for the Corsi Rosenthal box co-creator. Are portable air cleaners worth it? And what's the impact value for IAQ and or infection control?
Well, I think it's pretty well proven that you dramatically decrease, in fact, it is proven, you dramatically increase particle counts indoors by using either HEPA air cleaners or do-it-yourself products. And in fact, I was just reading a study yesterday out of California, and they were showing particle reductions with MERV 13 filters to MERV 16 filters versus in-room air cleaners. And they found that the in-room air cleaners were substantially more effective at reducing particle counts. It doesn't mean you can put them everywhere, but certainly in areas where you have a special need, they definitely help. Then they reduce the particle counts.
So I got a long question for you, but it goes right along with the placement, essentially, so following up on that question, the uncertainty of not knowing where the spread is and just being able to try to take your best guess on where to put a portable air cleaner, no matter what that is, and how best to set it up, whether it's in a commercial setting or just at your dining room table at home.
I'd be glad to answer that. Is that okay?
Go ahead.
Okay. It's interesting that there have been some studies showing that having it in the center of the room is helpful. You have the issue of what do you do with a cord when you have it in the center of the room. It's not very nice having an extension cord going across the going across a classroom floor. But we have found, strangely enough, you can put one of these Corsi Rosenthal boxes in a corner of a room that's 20 feet by 30 feet, kind of a classroom size. It's just a couple feet from the corner, the walls of the corner. And within 40 minutes, the particle count will be within 5% in all four corners of the room. And it's distribution. You have enough airflow, you have distribution. And yesterday or day before yesterday, an article was published in Indoor Air, the journal Indoor Air, so peer-reviewed study done by the EPA, three researchers out of the EPA, and they found exactly the same thing, that it really didn't matter where you put it in the room as long as you had the airflow. And what I tell people is these things will work. And there are three components to getting particle reduction. Number one, you have to have the filter. Number two, you have to have the fit. Just like Bob said, there's so many installations that are not properly done and don't have the fit, so the system's not going to work. And the third thing is you have to have the flow. The air has to be going through the filter in order to have any substantial reduction in particles or any substantial benefit from the air filter. Now, the advantage that a standalone unit has is that it's going all the time. Most air conditioning systems or heating systems, HVAC systems, are on intermittently, and so just the fact of runtime, one's running as long as people are there. I run mine 24/7, but the other one is running usually when the either it's too cold or too hot. Now, right now it might be cold enough in New England that you have them running all the time, but essentially you're limited by the runtime of the system. So flow is very important.
So going along with that flow, so where would you position that portable air purifier or air cleaner? Would you put it so it's flowing directly across from the traffic? Would you want to pull from the traffic? Do something you want to have hanging up high or started down low?
Yes. My preference is having the air going up rather than going straight out. This idea that you're going to be blowing particles from one person to another, I mean, theoretically that works, but that's just not the way particles move. I mean, and the idea that you put an air cleaner in, you're going to be blowing particles from one person to another, just on its face is ridiculous, because the particles aren't going away. They're airborne. They're sitting there. And if you're moving them, at least you're moving them so that you disperse them. It's another thing that I tell people. In order to remove particles and make a place safer, because the people are there, they're emitting the particles. You need to disperse them, you need to dilute them, and you need to remove them. There are three things that you have to do: disperse, dilute, and remove. And if you do those things, you're making a much safer environment. And I think the idea that you're going to blow the virus from one person to another is a non-starter. I just don't think it has any relevance.
Thanks, Jim. So going along this line with running these systems around the clock or not having them run very much, Bob, how would you suggest, or how do you advise balancing air filtration and air quality with increased concerns with energy consumption and CO2 when it comes to ventilating spaces?
Well, the problem is, as we increase the quality of filters, usually the byproduct of that is the resistance goes up and the energy costs go up, and they're also more expensive to replace. MERV 13s are more than a MERV 8, so you have 2 or 3 downsides to the filters being upgraded. But it's something that is part of the deal. You know, if you want to get more particles out of the room, we have in Boston City Schools, there's a HEPA air cleaner in every classroom, every single one, and it works, but that's an expensive process. You got to change them twice a year, and they're expensive. The filters themselves are fairly expensive. The air cleaners are expensive, but it's driven by the union more than the engineering department. But they want air cleaners, HEPA air cleaners in every single classroom in Boston, and we have that contract to change those. So it's expensive. They're not cheap.
And that's what they're justifying as the cost of quality air or a safe environment. Is that the way they're going, whether it's the energy, the time, the labor, the material, all into one?
Yep. I know when we bid the contract to change the HEPAs, there was only one out of bid because they didn't even know how to approach it. They don't even know where the classrooms are. So it gets expensive, but the reality is HEPAs work better than anything else. I can tell you that, better than UV, ionization, MERV 13. If you can swing that, it's worth it.
Great. Okay, so we know HEPAs work, but Jim, can you explain? We had a couple questions on how they work.
How they work?
How do HEPA filters work is a very.
I alluded to it earlier, but so you have the four basic mechanisms of filtration, and those are all working together. And a HEPA filter is a very tight structure, but it's still, the fibers still have to be working so that you maximize the potential of all four of the mechanisms, the filtration mechanisms. So that's straining, impaction, interception, and diffusion, and they all work together to create a very effective, very efficient filter.
Okay, Bob, this one I'm going to throw back at you because you just gave the answer regarding the energy. Have you seen new systems or retrofitted systems going with higher air volumes to able to use higher efficiency filters when needed?
Well, I get most air handling units that are reasonably new can handle a MERV 13. We haven't had a problem at all on that. Some of the older ones, not so much the case. You can go, even if it can't handle it at the beginning, you can go up and change the shivs in the air handling unit on the fan. Variable drives on the fans are useful because they'll pick up the fact that there's more resistance now. So, and the other thing about MERV 13, they load up quicker. That's another thing people overlook. MERV 13s can sometimes last, Jim was saying every quarter. Well, sometimes MERV 13s don't make that quarter because they're picking up more stuff, picking up more lint, picking up more dust, more pollen. Spring especially, we have big pollen season here, and those filters can get plugged in a month and a half. Sometimes later on in the year, they'll last 4 or 5 months. But the change-out cycle is always predicated by the contract, and it's usually 3 months. So the MERV 13s are pretty well spent by the time we get to them, if they're in an air handling unit.
I always love that people say, these filters are loading up too fast. And so they're getting the debris and they're getting the particles. That's the idea of filters, isn't it? Yeah. it's like, why would you complain about the fact that the filter is working and taking this stuff out of the air? Do you want to breathe it, or do you want it to be in your HVAC system? That's the job of the filter. Yeah, you might have to change it more often, but that means that it's working. It's doing what it's supposed to do.
So when you get that call, do you just say you're welcome?
When they say they're not lasting long enough,
they're loading up too quickly.
They're loading up too quickly. I usually kind of have a conversation just like I did, and I'm not sure what the people think. They're shaking their heads like this guy's crazy or something. But the bottom line is, we've had customers. We had a bakery that decided it couldn't use a more efficient filter because it was clogging up too fast. The filters were clogging up too fast. So they went to this less efficient filter. And I just happened to have a friend that owns a large mechanical contracting company. And he was telling me about this bakery that he had. And he said he went out there and they weren't getting any airflow. And he said, you know, the reason why was because all the ducts were just, these ducts, huge ducts, were reduced down to size of about 8 inches because they were covered with flour on the inside. So the flour wasn't getting on the filters, it was going inside the ducts. And then they literally had to replace the ductwork because it was just filled with flour. So yeah, you can take it out with a filter, or you're going to figure out some other way to deal with it.
And there's things you can do. You can change the filter style. You can go to a mini pleat. You can go, instead of a low capacity pleat, a high capacity pleat. There's certain strategies that can help extend the life of the filters that are simplistic. 4-inch filters obviously can hold more dirt and crap than a 2-inch filter. So there's different things sometimes you can change the track, sometimes you can't. If it's front loading, you just change the clips. So there's different strategies you can introduce that will allow those filters to last a little bit longer without going to great expense.
Right.
And following up on that, Bob,
that goes to your question, or your answer earlier about systems that are older systems and are having a little trouble with the increased pressure drop of a MERV 13 filter. If you can go to a 4-inch filter, 4-inch filters instead of 2-inch filters, has a dramatic decrease in pressure drop. So it definitely could help. Most residential systems, we're talking primarily about commercial, but most residential systems are improperly designed. They do not have enough airflow. Ducts are too small. The filter opening is too small. That's really where you need to worry about using a MERV 13 filter. But when you think about it, because the improved airflow of a 4-inch filter, most people, even with an older system and not having sufficient duct work and a size filter opening, they can accommodate a 4-inch MERV 13 filter.
So you guys both jumped the gun on me, and I appreciate it. That was fantastic. We had a question: how do you select the right filter, and what questions do you at least start with? And I think you just pretty much answered that. But do you have anything else to maybe add to that, with what questions you want to ask yourself when you're starting to look at that?
Well, most people, the great thing about our business, and people say, what's happening with new construction? Well, new construction is nice, but that's a very small percentage of our business. Most of what we deal with is existing buildings, and every building has filters, and filters need to be changed. And what we usually start out with is, what are you using now? Do a survey and figure out what they're using currently, and then ask them why they're using that. And then see whether or not there's something that you could recommend that might be able to improve their performance, either get a little bit of airflow for energy savings, or better performance in terms of particle removal. It's a problem-solving question. It's not like you need this. You need to figure out what the customer needs, and then you figure out a way to best accommodate what the customer needs.
Thanks, Bob. Any other add on to that, or did you pretty much lay it all out there? You're pretty good there. So, Bob, I'm going to throw this at you, because I know Jim's going to have an answer on this from talking to him a little bit earlier. We're seeing a lot of building operators are being questioned about it, and you're seeing more recommendations going towards indoor air quality. And really the question is, how would you propose the concept of IAQ monitoring or indoor air quality monitoring devices being installed for general view for occupants in that building?
Some owners don't want those things in their building because it's a report card that they may not want to share with everybody. But I would recommend a portable particle counter versus stationary particle counters all over the place. And if you've got an area that's hot, a hot issue area, you can go into that area with a particle counter and find out what you're at, get a better feel of what the IAQ situation is in that area. But to put them everywhere is expensive, and people, just like thermostats, people say, oh, I could have control of my thermostat. Well, indoor air quality particle counters are going to be the same thing. So I would recommend just get a portable one, and you can go around and do surveys, monitor it, see if it changes. And there's some pretty good particle counters out there that are portable, and they're not that expensive.
Thanks, Bob. Jim, you got something to add to that?
No, I'm a big believer in particle counters and CO2 meters and things that give you some idea of what's happening in indoor air. And I think ultimately what needs to happen to improve indoor air quality is that we need to measure it. And then we need to have an idea of what's happening, and then figure out ways to fix it. It may not be popular, as Bob says. The building owner may not like all the complaints that are coming in, but it's really important to be able to provide a better indoor environment. And I think that's the biggest thing that's changed in the last 2 years. Indoor air quality is all of a sudden people say, that's really important. All these studies have been there, and we knew this before, but the interest is heightened substantially, which is good. And I believe if you want to achieve something, you measure it. Measure CO2, you measure particle counts.
At the very beginning, in the last 2 years, there's been an increased awareness of what the filtration level is in a building. And in a restaurant I go to, they have a sign that they have MERV 13 filters in their air handling unit. Building owners will add that feature to their offering of perks that they might have. We measure indoor air quality, and some tenants like that. They feel better. They know they get better filtration. They know it's being monitored and measured, and it's a plus. So some people, if they're good marketers, can use it as a plus versus a minus.
And I think that's what's going to happen in places where you have a large number of people. I know in some countries, all the movie theaters are putting in CO2 monitors to show that the theater has good ventilation. And as Bob says, it is a marketing point. I believe that you should have CO2 monitors in airplanes. You can control the CO2 level in an airplane. They don't do it because of cost and because whatever reason, they don't always do it, but you can control it. I guarantee you, if you had CO2 monitors in the front of each section, first class and regular class, it had CO2 numbers that the airlines would figure out a way to get the CO2 and the ventilation in line where it needs to be.
Well, I have no doubt, but then you wouldn't be able to sleep as well on the plane.
That's a good point, actually, because that's exactly what happens. CO2 levels are high and we all fall asleep on the plane. I never realized why did I fall asleep on the plane every time I get on there? So now I carry my CO2 meter, and sure enough, it's 2,400 parts per million as you're loading the airplane, and I'm falling asleep. Of course, that's why you fall asleep.
Absolutely right. So I'm going to switch gears a little bit and get a little bit more technical. And Jim, I'm going to throw this one at you. What's the best way to analyze, and can you explain what it is before you tell us how to analyze an ASHRAE 52.2 test report for a filter?
Here are the things that I look at. Of course, you want to see what the final result is. You want to look at the E1, E2, and E3 because it gives you a good idea of how efficient the filter is on like this PM 2.5. You want to look at how the filter is construction, how many pleats per foot are in the filter. And then you want to look at the speed at which the filter is being tested. That's a critical number. There's 7 speeds allowed in 52.2. And you can vary the speed and it dramatically impacts the results. If somebody has a relatively resistant media, they're going to try to run it at 1180 CFM instead of 1492. That makes a huge difference. The velocity of the air the resistance of the filter and the velocity of the air are parallel, or they're equal to each other. The higher the velocity, the higher the resistance. So that's what I look at.
I'm going to add one thing to that. We have different manufacturers we buy from. We had one manufacturer that was saying this is a MERV 10 or 11, and then we check it out about 3 months later, it was down to a 7 or a 6. Other manufacturers, it goes up after it's in the air handling unit. So you can see a post installation reality that the filters don't stay at that level that they tested it at, and they don't really want to share that. But if you watch it, do particle counters, you can find the ones that the culprits that are going backwards instead of going forward or up.
Yeah, and they're not all the same. I mean,
yeah,
you can have MERV 13 electret filter, and it holds its charge pretty well, and it's going to wind up pretty close to MERV 13 after 3 months. You have another one that drops really quickly. It drops in 6 weeks down to a MERV 9 or something, and it varies so much. It's really hard. And I'm not a huge fan of Appendix J, and the reason is I'm not sure it really tells us good answers. You know, it goes back to this thing we were talking about of PM 2.5. If you had a better MERV chart where PM 2.5 was more relevant for filters like a MERV 8 filter, MERV 10 filter, MERV 11, I think Appendix J would be fine. But we don't. We're saying that a MERV 8 with efficiency of 3% at particles under 1 micron is the same as one with 25 or 30%, and they're not the same. Even 25 or 30% in a filter will dramatically decrease particle counts because of recirculation.
Well, I think you just covered another question there, so thank you for that add on there.
Wind me up.
Yeah, well, careful. I'll get you all sorts of fired up with some of these. So actually, let's go back to a couple of follow-up questions. We're coming about a quarter till, and I know I want to get to a couple of these questions that were submitted while you guys were giving some pretty awesome answers. And someone asked if the Couture Rosenthal box is less effective at removing particles and COVID-19 virus than a HEPA filter, a HEPA air filter cleaner, a portable cleaner, I think we're looking at here. Jim, can you touch on that?
Okay, I'd be glad to. This goes back to what I said before. It's filter, fit, and flow. The filter is definitely, if it's a MERV 13 filter, it's definitely not as efficient as a HEPA filter. And yet, a number of researchers, including myself, have done a head-to-head with a Couture Rosenthal box with MERV 13 filters against a high-end HEPA. And in the room, the particle counts at all particle sizes is less using the Couture Rosenthal box. I'd be glad to show people all the data on it. It's the same thing that comes out. What happens is people believe that. They can't believe that since the filter is so much less efficient, how could it possibly work? But it has to do with the flow through the filter. And then my latest theory is it's the recirculation, and going through the filter a second time or a third time dramatically increases the performance of the unit and is more effective at lowering the particle count. Filter, fit, and flow.
So having those higher airflows will actually increase something like a log reduction and be able to get you to a point where it's being quite effective, and that's what I'm hearing there. Yes,
I mean, this has been done by university researchers, people who are experts in particle counting, and they all come up with the same result. Even the thing with the EPA that came out last week, it showed that the Couture Rosenthal box was substantially more effective on all particle sizes than the HEPA filter they tested. We'll figure.
All right, I got another one here that is a follow-up, but in HVAC systems and specifically on the filters, there's suggestions that essentially that they can be contaminated. These filters can be contaminated with viable organisms. Have either of you seen any research supporting or going against this idea? And if there is any research, what do you see the industry moving towards to rectify that?
I've seen nothing on that. Jim might have. I haven't seen anything on that.
I've been following this for the last 2.5 years, and there have been people who have researchers who have found RNA of COVID on filters. No one has been able to come up with any viable COVID on a filter at this point, and people have been trying for 2.5 years. And I think there are a number of things that happen. One, it's going to capture the particles, but as I said earlier, a virus doesn't exist on its own. It needs moisture and protein in a capsule, if you will. And an air filter is a pretty inhospitable environment. Air is moving at 500 feet a minute. There's on the actual surface of the filter, there's very little humidity. It just doesn't last very long. We're just not seeing it. On the other hand, to be cautious, if I'm changing filters in a hospital, or I know that the air handlers have been on a COVID ward, I'm going to guarantee you that my people are going to be wearing masks and gloves and handling those as potentially hazardous material. Not that anybody's found anything, but our job is to make sure people are safe.
Yeah, I've seen a lot of contractors continue the trend of, or I shouldn't just say contractors, anybody that would be changing a filter, continue the trend of wearing a mask or having some extra protection, because what they're changing is there for a reason, and that's to take the bad stuff out of the air.
Right.
Bob, here's one that was asked right when you were talking about the leaky equipment, the older equipment. If you can't replace the equipment, is there a way to, or any suggestions to be able to use a higher efficiency filter or have that Mervate filter do its job better? Do you have any suggestions there?
Well, the Mervate filter is going to be a Mervate filter, but you can put in higher, like an 11 or a 13. But you probably, if it's an older unit, it might be a direct drive, which is going to be more difficult to fix than if it's a variable speed drive. You get shivs, you got belts, you got all kinds of stuff in that air handling unit that can be upgraded and to handle more static pressure. So and it can be done.
Is that something you want to have engineered, or is that something an HVAC knowledgeable contractor or facility person might be able to do?
Well, I think if it's a sophisticated building owner and maintenance department, they can usually address things like that, or they can bring in their own mechanical contractors. It's not a big deal, but it takes time and it's effort to do it. But if you don't have the pull through that unit or the push through that unit, you're not going to get much air going through it. So you might as well address it, or give up the ghost of going to higher efficiencies.
When you go to that higher efficiency, or you make that upgrade to the fan, is there a way to help get that old filter rack to get sealed up better, to reduce that bypass or eliminate that bypass and get that true efficiency?
We've done that. We've actually gone a unit and it's a disaster. So we'll just say, you need to replace these frames and gasket them. And they usually listen, because they realize that the filters in the unit aren't going to perform well if they're not gasketed. The frames aren't butted next to each other and sealed. There's all kinds of things that when contractors do it, they just put the frames in. I've seen units where the frames weren't completely filling the unit, and they had a 6-inch gap on one end, and they think that's good. That's fine. No, it saves the pressure drop, but that isn't how you really want to set up a filter rack. But they don't even know. They don't care. They just shut the door and walk away. So you get a good blank off panel, but somebody's not looking at it.
Right.
Simple solutions can go a long way.
Yeah.
Jim, what's the effect of that bypass? I'm going to try to start wrapping up here and clean up these, maybe one more question each before we close out. But talk of bypass, having a MERV 13 filter in a piece of equipment that has bypass, what's the effect on that?
If you have 1 inch of opening, you probably are making your MERV 13 filter into a MERV 8. So air is going to move the path of least resistance, and a lot of it's going to go around the filter. It's not going to go through the filter. Dr. Jeffrey Siegel did some really good studies on this and found essentially that it's, in fact, even less than 1 inch, a half an inch converts a MERV 11 into a MERV 7. And this was in residential units, but still, the theory is the same. Air moves the same in residences as it does in commercial buildings.
And Bob, the last one, thank you for that, Jim. I think that was, hopefully everyone heard that. When you have a leaky system that Bob's talking about, and you make the upgrades, but you don't seal that filter in properly, that drops significantly, and essentially you're paying for something that's not able to do its job, which is scary. Bob, adding on to that question, for an air handler, or at least the assumption is the air handler that you're talking about retrofitting or upgrading, can you do that in a univent, in a school situation or something along those lines to increase the airflow, to use a 13? What's your experience there?
I'm not a believer that would work.
Fair enough.
Univentilators are usually fairly old, even if they're new. It's hard to get anything more than a 1 inch filter in there. So you're not going to see a 2 or a 4 until the univentilator manufacturers change their approach. Right now, a 1 inch polyester or 1 inch pleat, it isn't going to be sealed in that unit very well. I've never seen it happen that way. So.
Great. Well, for the most part, we covered quite an array of questions. Do you guys have any closing comments before we shut down, and some initial final thoughts? In fact, let me do it this way. Bob, do you have any closing comments? Because I'm sure Jim will have a couple comments before we close out.
I just think that we're seeing so many changes, and we'll see more in the next 5 years. I mean, we're looking back 2 years, but I think you're going to still see changes coming in the next 3 to 4 years that are going to change everything. So, if you look in the rearview mirror, there's a lot of stuff, but I think we're going to see stuff in the front of our view.
Yeah, and I would say that what's encouraging to me is that as an industry, the filtration industry is becoming more professional. We are better trained, better prepared, more knowledgeable, and have a higher level of ethics. I think it's a really great industry to be in right now. I think there are a lot of advances that are taking place in the last couple of years, and are going to take place in the future. We have the momentum going in the right direction.
Great. I hope you're both right on the good stuff. At least I think I think everyone's learned quite a bit. I've certainly learned a couple things and had some gears turned on some of those answers. So I really do appreciate the time. First of all, I want to say thank you to everyone that joined us. Thank you for everyone submitting questions during. We had a lot of questions submitted during, and we had a whole bunch before. So I really appreciate all the thoughtful time that people put into it. And I'm going to pass it off to Tony.
Matt, you did a great job. You're going to put me on a business here. I think you're going to be the new webinar host. You did a great job. Thanks so much, Matt. Jim and Bob. Wow. This was everything I had hoped for as far as like tapping into your knowledge show. So your experience and being veterans in the industry certainly shows today. So thank you so much for that. Kathleen, thanks for the comment here. She said, thank you. That was fun. I was fun. I think it was if you're a nerd or a geek for air filtration, indoor air quality, yeah, definitely was fun for sure. So thank you so much for the great questions. It was a great conversation. There's going to be a survey coming out right after this closes. And so please take part in that. We'd love to get any feedback, what you liked, what could we improve upon. If you like more of these, Matt is on the education and training committee, we'll certainly bring it back to the committee on what sort of webinars we do in 2023 and beyond. So if you like this sort of format, please do indicate that you like that. So again, thanks so much, everybody. I just have on the screen here how you can follow us if you're, actually, it's interesting, just kind of as a closing thought, I talk to and see many longtime NAFA members that don't like our page. So if you're a NAFA member, make sure you're liking our company page. Make sure that you are following us in all the places. So that way, when we share it, you'll be able to see us. By the way, when we do share out stuff or you share interesting information that maybe you could tag NAFA on if it's appropriate, tag NAFA kind of in context of what you're saying. We'd be happy to like and share that stuff. So I do see a lot of pictures of dirty filters and problems in the area. So if you guys see stuff, we would love to take part and share, and obviously be here to educate the industry and the public on best practices in air filtration. So thanks so much. We will close it out here, and happy holidays, everybody. And we'll see you in February for our next webinar. Take care. Bye-bye.
Tony.
Thank you. Thanks, guys.